This is the video on shear force and bending moment diagram. First video. The question is find the beam reaction RA and RB for the following beam and draw the shear force diagram. Now let us see how the beam is. Now this is the beam. It is simply supported at A and B. The total span of the beam is 6 meter. At 2 meter from A there is one load 16 kilonewton acting downward. At 4 meter there is another load 22 Newton. The points A, B, C, D are as shown. So this is the beam. For this beam we want to draw the shear force and bending moment diagram. First what we will have to do is we will calculate the reactions RB and RA. Now how to calculate the reaction RB, which has been already explained in last two videos. So in 2-3 steps we are going to calculate RB. So taking moment about A, clockwise moment positive and anti-clockwise negative. We are taking moment about A to calculate RB. So moment of RA about A is 0. For this 16 Newton, it is at a distance of 2 meter and the moment is clockwise. So we write down RB is equal to 16 into 2 plus. Now for this 22 Newton, it is 22 into distance from A is 4 and moment is clockwise. So plus 22 into 4. Put this whole thing in bracket, divide by the distance between A and B. That is here 2 plus 2 plus 2 is 6. So divide by 6 and put the bracket here at the beginning and here. Now take the calculators in your hand and do the calculations. Bracket open, 16 into 2 plus 22 into 4 bracket close divided by 6 is equal to, you will get RB is equal to 20 Newton. Only these two steps are sufficient here to calculate RB. Now let us see how we calculate RA. RA will be equal to, what we do is the forces which are going down we take it positive and the force which is going up, that is RB, we take it as negative. Now 16 and 22 going down, so plus 16 plus 22, RB going up minus RB. Substitute the RB value as 20 from here. So 16 plus 22 minus 20. Take the calculators in your hand and do the calculations. 16 plus 22 minus 20 is equal to, you will get RA as 18. Now here write the value of RA below A and RB below B. So this is RA 18 and RB 20 Newton. Now let us come to the basics of shear force. How we draw the shear force diagram. What is a shear force? Shear force is that we take a section and we consider left hand side or right hand side of the beam and do the summation of all the vertical forces, and that summation is called shear force. Now let us see how we do it. Now initially I am taking a section between A and C. So this is my section XX, which is between the point A and C. Now if I consider only the left hand side, so on the left side there is point A and RA, only one force, how it will look like. Here I am showing it. RA, that is 18 Newton, and now if I do the summation of all the forces on the left hand side, I have only one force going up. Here the sign convention which we are going to use is, if I am drawing the shear force diagram from the left hand side, then going up is positive. So shear force is equal to 18 Newton. Now here there is only one force going up, so 18 Newton. So shear force is 18 Newton at section XX. Now I can change this section XX now, and I can take it anywhere at say 0.5 meter from A, or 1 meter from A, or 1.5 meter here from A, or at point C, that is 2 meter from A. And if I consider the left hand side, there is only one force RA, that is 18 and going up. So shear force from A to C, anywhere if I take the section, shear force is 18 Newton. So shear force is 18 Newton from A to C. It is constant. So now how we show the shear force? Now this is the beam AB. Now at A it is going up by 18 Newton. RA, the force is going up by 18 Newton. So from here to here, this is the line of 18 Newton. And now from A to C, if I show the shear force anywhere, then it is everywhere it is 18, 18, 18, 18, 18. So it is a straight horizontal line up to C, because everywhere from A to C it is 18. So we draw a horizontal line of 18 Newton from A to C. Now what I do is I take a section between point C and D. Now if I consider a section between C and D, again I'm calling it section XX, and now if I concentrate on my left hand side of the beam, how it will look like. So the left hand side, there are now two forces, RA going upward, and there is another force at C, 16 Newton, going downward. So now when I see the left hand side, I have two forces, RA going upward at point A, and at C, 16 Newton force going downward. Now if I do the summation of all the vertical forces on the left hand side, then what will happen? RA is going up, so 18 plus. Now this 16 is coming down, so it will be taken as minus. So it will become 18 minus 16, that is 2 Newton. So shear force will be equal to 18 minus 16. RA going up, so 18 is plus, 16 going down, so minus. So 18 minus 16, 2 Newton from C to D. Now from here, suppose at C, if I come just to the little right, say here this point at 2.5 meter from A, or here 3 meter, 3.1, 3.2 up to D. Anywhere between C and D, if I take a section and I consider the right hand side, then there are two forces, 18 plus 18 and minus 16, and the summation is 2 Newton. So from C to D, anywhere the shear force is 2 Newton. From C to D, anywhere I take a section, there are only two forces, plus 18 minus 16, and the summation is plus 2 Newton. So shear force from C to D is 2 Newton. So at C, there is a vertical point load coming downward 16. So here we come down by 16 vertically. So this is 16. Now when I do 18 and this minus 16, this is the 2 which is balance remaining here, so 2 Newton. And from C to D, anywhere everywhere it is 2 2 2 2. So this is a horizontal line of 2 Newton from C to D. So what we have to remember, that when there is a point load acting on the beam and there is no other force, then shear force diagram is a horizontal straight line. And wherever there is a point load, if it is 16 going down, you go down by 16. If it is 18 going up, you go up by 18. Now here this is 22 going down. So from this point, we have to go down by 22. Now suppose, now I have taken a section between C and D. Now I take a section between D and B. So now I take a section between D and B. Now if I look at the left hand side, now there are three forces, 18, 16 and 22. So how the section will look like left hand side, that I am showing here. This is RA going upward, 18 at A, then 16 Newton downward at C, then 22 Newton going down at D. Now when I take a section between D and B, this section line here, and if I see the left hand side, then this is the left hand side which I can see 18, 16, 22. Now 18 going up positive, 16 is minus, and 22 is also minus. Now we know here the shear force is at D here is 2, and I can directly do 2 minus 22 because that is the only new force which we have added. So shear force I can do 2 minus 22 is equal to minus 20 Newton, and that is the shear force from D to B. Or I can do 18 minus 16 minus 22. 18 minus 16 minus 22. That will also give me minus 20 Newton. So from here we go down by 22 from this point. So from this point, this is the baseline. If I reach from here to this beam line, I am reaching 0. So from this line up to this baseline is 2. I want to go down by 22. So 2 minus 22 is minus 20. So when I cross this baseline and I'm coming down, this is the negative zone and this is my minus 20. This dark line of the beam is the baseline and that is a 0 line. So from here 0 I have come up by 18. Now when I coming down, that means I have come by on the negative side. So this is my minus 20. Now anywhere from D to B, the shear force will be minus 20 because the summation of these three forces, whether I do it here, 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 anywhere when I take the consider the left hand side, there are only three forces. If I take a section here and consider the left hand side, there are only three forces. If I take a section here, again there are only three forces, and the answer will be minus 20. Here, 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 anywhere from D to B, I take the section and do the summation of the vertical forces, it will be minus 20. So from D to B, here will be a horizontal line of minus 20 because shear force from D to B anywhere is minus 20. So this is how I am showing this minus 20 horizontal line. So anywhere here it is minus 20. At B, what is happening? There is one vertical force RB going up by 20. So when I reach here, I have to add this plus 20 going up, so 20. So this minus 20 and plus 20, it will become 0. So here we go up vertically by 20 Newton because RB is going up. So what happens here? We reach here at 0. Now our sigma Fy is 0. So here at the end of the shear force, we must reach 0. In case in the exam we do some mistake, and if I don't get this as 20 and if I get it after adding RB, if I don't get this answer at 0, I get it as minus 1, plus 1 or plus 2, any other answer than 0, it just means I have made a mistake in my shear force diagram. So this is how we actually draw the shear force diagram. But the question is it in the exam every time I will show section XX between A and C, then draw this left hand side and do calculation, then again take a section between C and D, draw XX line, and I show the left hand side like this picture, and then I do the calculation 18 minus 16 is equal to 2. Then again I take a third section between D and B and draw a section XX, and I show this full left hand side and do the summation to minus 22 or 18 minus 16 minus 22, and then draw the shear force diagram. No, we are not going to do such huge calculations. We are just going to draw this shear force diagram directly. And how to do it, that also I am going to teach in detail. Now this is the same beam diagram here, 2 meter, 2 meter, 2 meter, A, B, C, D. At C 16 Newton force, at D 22 Newton force. Okay, we do the calculations of RB as it is done previously. RB is equal to bracket open 16 into 2 plus 22 into 4 bracket close divided by 6. We take the moment of all the forces about point A, clockwise positive, anti-clockwise negative, and we get RB is equal to 20 Newton. Then we calculate RA is equal to, here the sign convention is going down positive, going up negative, 16 and 22 going down positive, substitute value of RB going up, so minus 16 plus 22 minus 20, 18 Newton. Show the RA RB in the figure. So the reactions, RA 18 Newton, RB 20 Newton. Now I draw the shear force diagram. What we do? First we draw the beam AB. That is our baseline. This is our baseline, zero line AB. Now here RA is going up. Left hand side going up is positive. So if RA is going up by 18, here at A I draw a vertically upward line 18 and I go up by 18 Newton. Now A to C there is no force. So straightway this shear force will remain 18 from A to C. So from A to C draw a horizontal line. At C force vertical is coming down by 16, so from at C come down by 16, so 18 minus 16, balance is 2 Newton. So from C to D the shear force is 2 Newton. So here 2, so this 2 plus 16 is 18, and here this is 16 is coming down, so from this point I have come down by 16, and here the balance is 2 Newton. So from C to D will be a horizontal line of 2 Newton. Now at D the force is 22 going downward, so here we have to go down by 22 vertically down. Now when I come down by 2 Newton I reach 0. So here this is 2 plus and this is 22 going down means minus. So 2 minus 22 is minus 20. So here below 0 I have to come down by 20 Newton. So this 20 plus 2 total is 22. So this vertical line from this point up to this point is 22. So from this point I have come down by 22, and here when I come down by 2 I reach 0. Below 0 I come down by 20. So this is my minus 20. I have come down below this dark blue baseline, means this 20 is minus. Now from D to B the shear force will remain minus 20. So one horizontal line from here, that is of 20 Newton. Now this is minus 20 here, but here RB is plus 20 going up. So from this point I have to go up by 20. So when I go up by 20 I reach 0. So minus 20 plus 20 will give me 0 and I reach the baseline 0. So this is how I draw the shear force diagram directly. If I want to write the calculations for the shear force diagram, what we write? Shear force calculations. Shear force at A. Here at A the shear force is the RA going up by 18, so it is 18 Newton. If I come little left of from A to C, shear force is 18. So if I am little left of C, say at 1.99, so what is my shear force here? At the left of C is 18. So C shear force C left is 18. But what is the shear force at here right? If I cross C and come just a little right of C, it is 2 Newton. So C shear force C right is 18 minus 16 is equal to 2 Newton. 16 going down, so we take it minus, and now the summation becomes 18 minus 16 is 2 Newton. So shear force here is 2 to the right of C, to the left of C it is 18. C left is 18 and C right is 2 Newton. Now here at the D left is 2 Newton. So shear force D left is 2 Newton. From here to here it is 2. So shear force C right is 2 Newton. Here at the right of C is 2 Newton, and at the left of D is again shear force at left D is 2 Newton. If I come to the little right of D, this 22 gets added. So shear force D right is 2 minus 22. Now 22 going down, so it will be taken as minus 2 minus 22, that is minus 20 newtons. So if I cross this point D and come little right of the D, then here it becomes minus 20. Now here when I am on the left of B, it is minus 20 only, because here it is a horizontal straight line. So shear force B left is minus 20, and shear force at B, when I reach here at B, here it becomes minus 20, and this 20 plus gets added, RB, so minus 20 plus 20, it is 0. So at this point shear force at B is 0. These are the shear force calculations which you can very easily write. Now whenever in the exam you have to draw the beam diagram, then the beam calculations for beam reaction, then shear force diagram and the shear force calculations. Take care that when I am showing the shear force at RA, it must come in the beam diagram in the same line. When I am showing this 16 coming down, I must be in a straight line with C, this is 16, or when I am saying this 22 coming down at D, so this must be in one straight line vertically here and at B. So it is, so we don't write the beam reactions below the beam diagram, we always write it on the right hand side, and on the left hand side we will have the beam diagram, then the shear force diagram, and then the bending moment diagram. Now let us learn how we draw the bending moment diagram for this beam. Now I am drawing the beam. Now find the reactions at reactions RA RB for the following beam and draw the bending moment diagram. I am considering the same beam again, AB, with the 6 meter span, and at 2 meter C 16 Newton force, and at D 22 Newton force. The same beam I am considering. So the reaction also will be same. RB is equal to 16 into 2 plus 22 into 4 in bracket divided by 6, that gives RB as 20 Newton. RA is equal to 16 plus 22 minus RB, or 16 plus 22 substitute value of RB minus 20, you get RA is equal to 18 Newton. Show the RA and RB in the beam diagram. RA is equal to 18 Newton and RB is equal to 20 Newton. This much problem is same as we find out the beam reaction. Now how we do the draw the bending moment diagram. Here what I do is I take a section between A and C as section XX. So this is my section XX between the point A and C, and it is at a distance of capital X from point A. Now what I do is I consider only the left hand side of the section XX. Now how it will look like. On the left hand side there is only one force, that is RA 18 Newton at A. Now I want to take a bending moment at section XX, considering the left hand side only. When I consider only the left hand side and take a moment here at this point, what will happen? I get the answer. Bending moment here will be RA is 18 into this distance is X. So bending moment at section XX will be 18 into X. Now this is very similar to Y is equal to mx, where m is 18 and this is x. So if this x is say 0.5 from A, then this will become 18 into 0.5, that is 9 Newton meter. Now if I substitute x is equal to 1, that is this section line I shift it from here to here, say at 1 meter from A. What will happen? This figure x value will be 1 and it will be 18 into 1, that is 18. Similarly, if I want it at 1.5 meter from A, I will substitute here 18 into 1.5. If I want it at point C, my x will become 2 meter. The distance from A to C is 2 meters. So this x value will become 2 meter. So if I substitute here 2, it will be 18 into 2, that is 36. So what happens here is, as the x value goes on increasing, this bending moment also goes on increasing. Now A is a simple support. So at this support A, MA, the bending moment at A will be 0. And as we go on increasing the value of x here like this and go towards C, the x goes on increasing 0.5, 1, 1.5 like that. So as the x is increasing, the bending moment also increases from 0, and at C it becomes 18 into 2, that is 36. So how we show the bending moment? So bending moment at C is 18 into 2, 36 Newton meter. At C, this x value from A, the distance of C is 2. So x will become 2 meter at C. So 18 and substitute value of 2 as x, it is 36 Newton meter. So how we get it? So this is the baseline. At A it is 0. At C it is 36 Newton meter, and in between it slowly increases in a straight line. This is a equation y is equal to mx straight line. So this vertical y ordinate is bending moment, and x is this horizontal distance from A. So this vertical ordinate here is 36. So this is the bending moment at C, 36 Newton meter here, and in between it is an inclined straight line. So you have to remember that when there are point loads, shear force diagram is a horizontal line, whereas bending moment diagram is an inclined straight line. Now if I take a section between C and D, let us come to the next. Now here I take a section between C and D. This is my section XX between C and D. Now my distance x is always from A. So from A up to this section line is the distance x, and this 16 Newton force is at a distance of x minus 2, because this AC distance is 2 meter. So from this x, this 2 is gone. So if I say do the calculations for this 16 Newton and this section XX, so this distance from 16 Newton to the section line XX, it will be x minus 2, because this distance AC is 2. So if I, and from A to this section line is x. So when I subtract these two, I get this distance. So x minus 2 is the distance of 16 Newton from the section XX, and x is the distance of this 18 Newton force from the section line XX. Now I want to take bending moment at XX at here. How I do it? Now let us show only the left hand side of the beam. This is RA at A, and the second force now which comes into picture is 16 Newton force, which is at C. Now when I take this section line XX and consider the left hand side of the beam, now I have one force RA and another force is 16. So this is RA 18 going upward at A, and this is the 16 Newton force coming downward at C. If I do now the bending moment at XX, how I will get? So bending moment at XX will be 18 into x. This is 18 here, and its distance is x. So 18 into x. Going up here, the sign convention is if the force is going up, we take it positive. So 18 into x, bending moment is positive. This 16 Newton is coming down, so it is minus 16 into, now distance here for the section line XX, the distance from the 16 Newton is x minus 2. So 16 into x minus 2 is the moment. So this is the equation for the bending moment equation. Now at point C, this x is equal to 2. From here to here, this distance is x and it is 2. If I substitute a value 2 here, Then this is 2 minus 2, 0. So this 16 into 0 becomes 0. And here it is becomes 18 into 2. So again it is same 36. If I substitute this x as 2, this value becomes 0 and it becomes 18 into 2, that is 36. And when I write this equation xx, I must get the same value 16 here also. When I substitute here 2, and if I'm not getting this 16 and I'm getting some other answer, that means this equation which I am writing, something is wrong in that equation. Now at point C, the bending moment is 36. At point D, this value of x from A, it will become from here to here 4 meter. So if I substitute, I want the bending moment at D, I'll substitute x is equal to 4. So 18 into 4 minus 16 into bracket open, x is 4, so 4 minus 2 bracket close. Do these calculations, take the calculators in your hand. 18 into 4 minus 16 into bracket open, 4 minus 2 bracket close is equal to, you will get it as 40 Newton meter. And here also again this is a inclined straight line, this is also a straight line equation. If I substitute C is equal to 2, sorry, x is equal to 2, I get the bending moment at C. If I substitute x is equal to 4, I get the bending moment at D. If I want it here somewhere, say I want bending moment at 3 meter from A, here at center, I substitute the value x is equal to 3 in this equation. I get that. If I want at 2.5, say from here at 0.5 meter, that is from A, if I want the bending moment at 2.5, just I substitute a value of x as 2.5 here, and I get the value of bending moment at 2.5 meter from A. So anywhere between C and D, if I want the bending moment, then this is the equation, and it is a inclined straight line. Now my bending moment at D is 40 Newton meter. So here I take a point of 40 and draw an inclined straight line. Let us see how we do it. This is the point of 40, and I join this 36 and 40 with an inclined straight line. And bending moment at D, this is the bending moment at D, 40 Newton meter. Now I can calculate the bending moment when I take a section here and consider the left hand side. I get two forces. I can even consider a section here between D and B. Let us see how we do it. Now I consider a section between D and B. This is the section XX. And now I consider the distance x from B. Distance x is, my x distance is from B. So if I consider here, when I take a section XX, if I consider the left hand side, then what happens? I have to do the calculation for three forces. One, that is 18 Newton, 16 Newton and 22 Newton. I have to consider the three forces if I consider the left hand side. But if I consider the right hand side, there is only one force. So here considering the right hand side is very easy. And so I am considering only the right hand side, and this is my section XX. So how the right hand side will look? This is RB20 and this is 22D. Okay, I am showing the full beam up to point D. Now here, if I want a bending moment at section XX, it will be 20 into X. Only 20 into X, and 20 going up, so positive. So 20 into X will be my bending moment at XX. Just like here you get it 18 into X, here I will get it 20 into X. And it is a straight line, y is equal to mx. So now this is a simple support at B. So bending moment at B is 0, and as the x here goes on increasing from 0, the bending moment will go on increasing. And how much will be the bending moment at point D? At point D, it will be 20 into 2. So this is 20, and from B to D the distance is 2 meters, so 20 into 2, that is 40. Now you will see, if I do the calculations from here, I get bending moment as 40 when I consider these two forces, and I take a section here, my section is here, and I consider the left hand side and consider these two forces, then I get the bending moment as 40. If I consider the section here and consider the right hand side of the beam, then my point is here, and right hand side there is only one force 20, and the distance is 2 meters, 20 into 2, and this is going up, so positive. So 20 into 2 plus 40, here this is plus 40. So whether I do it from left hand side or whether I do it from right hand side, the answer of the bending moment does not change. And here the bending moment is 0, and here at D it is 40, and in between it is an inclined straight line. From point B here 0, it goes on increasing, and at D it becomes 40. So here I just have to join one inclined straight line. So this is the line, and this is the bending moment diagram. So what you have to remember is, if it is a point load acting on the beam, the bending moment diagram is an inclined straight line, and its equation is something like this: y is equal to mx, and this is how we draw the bending moment diagram. Now the question is, in the exam, when we are said that draw the bending moment diagram, is it that every time I will show this AC, one section line here at X, then again another section line between CD like this, and third section line between D and B like this, and this X, and draw a free body diagram AC, then this, and again second free body diagram, and then again the third diagram, and do the calculations? Are we going to do all this? The answer is no. We really don't have so much of time in the exam. So how to do it? Very quickly, let us see. This is the beam A, B, C, D, 2 meter, 2 meter, 2 meter. A at C, 16 Newton force going downward. At D, 22 Newton force going downward. We calculate RB. You have to calculate RB in one sentence. 16 into 2, take moment about A. 16 into 2 clockwise, 22 into 4 clockwise. Do this divided by distance between A and B, that is 6. So bracket open, 16 into 2 plus 22 into 4 bracket close divided by 6, you get RB is equal to 20 Newton. For RA, going downward positive, 16 plus 22 going down positive, 20 going up, RB 20 going up, so minus 16 plus 22 minus 20, that will give you RA 18. Show the reactions in the of the beam, RA 18 and RB 20 Newton. Now let us draw the shear force diagram here first. So take a baseline AB, this is the baseline. At A, RA going up by 16, we start always from the left hand side, and the sign convention for the shear force diagram is left hand side going up positive. So RA, from the left we start, RA 18 going up, so we will go up by 18, vertically go up by 18. Now A to C, no force, so draw a horizontal line of 18. At C, 16 going down, so go down by 16 Newton. Now when you go down by 16, 18 minus 16 is plus 2. So here 2 is balanced. C to D, horizontal line of 2 Newton. At D, now there is 2 Newton, come down by 22. So 2 minus plus 2 minus 22, so that is minus 20. So above the baseline is 2 Newton, below the baseline is minus 20. Total we have come down by minus 22. And now D to B, no force, so shear force will be minus 20. Draw horizontal line of minus 20 up to point B. At B, RB is going up by 20, so go up by 20. So when we go up by 20, we reach 0. This is how we draw the shear force diagram. The shear force calculations. Shear force at A is 18 plus 18. Shear force at C left is 18, same because it's a horizontal line of 18. Shear force at C right will be 18, and now 16 is minus because 16 Newton is going down. So 18 minus 16 is 2 Newton. So here on the right it is 2 Newton, and on the left it is 18. Then at D left is 2 Newton. Shear force at D right will be 2 minus, now come down by 22. This 22 is going down. So 2 minus 22, that is minus 20 Newton. So here on the right it is minus 20 for D. Then up to B it is 20 only. So shear force B left is minus 20. And at B, here there is a vertical force 20 Newton RB, so minus 20 plus 20. So shear force at B here, that is at this point, it becomes 0. Here at the left it is minus 20, and at B it is 0. This is how you write the shear force calculations. Now let us come to the bending moment diagram. So first draw a baseline. Now shear force bending moment at A, as it is a simple support, is 0. Bending moment at C, when I consider the point C and consider the left hand side, there is only one force, 18, going up. So 18 into 2 will be the moment at C for this RA. So 18 into 2 is 36, and RA is going up, so bending moment is positive. So from at A it is 0, at C it is 36, and A to C is an inclined straight line. So this is an inclined straight line, and bending moment at C is 36 Newton meter. Now what I do here is, I can directly come here. Bending moment at B is 0, and bending moment when I want it at D, and I consider the left hand side, there is only one force, 20, and its distance from D is 2 meters. So 20 into 2, 40. So bending moment at D is 20 into 2, 40, and RB going up, again it is positive, so plus 40 Newton. And at B bending moment is 0. So here bending moment is 0, at D it is 40. In between D and B, inclined straight line. So this is the 40 Newton meter. And between C and D, again it is a inclined straight line. So just join a inclined straight line. This is how you draw the bending moment diagram very quickly. How to do the calculations. Bending moment at A and B, as it is a simple support, it is 0. Bending moment at C is 18 into 2 from the left side, and this is 36. RA going up, so positive. Bending moment at D, consider this much part only between D and B, so consider the right hand side only from D. So when you consider only the right hand side, you get only one force, 20, and into 2, take a section at D and consider only the right side, and right side there is only one force, 20 into 2, and going up, so positive. So 20 into 2, that is 40 Newton meter. So this is how you do the bending moment calculations in the exam, and give the name shear force diagram and bending moment diagram. In the exam, take care that on the left side you have the beam diagram, shear force diagram, and bending moment diagram. And when you show the D, here the shear force should show at D should be here like this, and the bending moment in one straight line, vertical line, this 16, here this 16, and this 36. Bending moment at C, all of them must be in one straight line. So this is how you draw the shear force and bending moment diagram. And on the right side, do the calculations very systematically, very neatly, and as far as possible, do it in such a way that the diagrams and the calculations can be viewed on the same page for the examiner. He doesn't have to shift the pages when he is observing the calculations and the diagram. It should not happen that diagram is on one page and the calculations are on the next page, and every time he has to shift and see what you have done. So take care that the diagram and the calculations are on the same page. So we will take few more examples like this in the next video. Be a master.